elimination is another way to solve systems of equations. So when you have two equations and two unknowns, it's called a system of equations, and they come up a lot of times in real life situations, as we'll see in a little bit. Minus 32 and 3x plus 6y equals 48. 48. Okay? Does anyone know already how to solve a system by elimination? Anyone know how to do this? Yeah. So elimination means you eliminate one of the variables, either the x's or the y's. Does anyone notice something special about this 6y and this 6y?
They're the same.
They're almost the same, except one's a negative and one's a positive. Okay? So if you see something like that, a very easy way to solve this system is by adding these two equations together. So you add the entire equation to the other equation, because you add the x's. What's 5x plus 3x?
8x.
8x. And then you add the y's. What's minus 6y plus 6y? 0y. So those disappear, you see? And what's negative 32 plus 48? Remember, you're adding 16. And then all I have to do is divide by 8, and I get that x equals 2, right? And I'm done. So a lot of times you'll see a system in which one variable, one set of either the x's or the y's are just the opposites of each other, and then you just add the equations together, and I've eliminated one of my variables. I still have to find the other variable, okay? So, the other variable. So to do that, I want to find out what y is, and this is a little more complicated than that. You can't plug directly into an equation and find y. So you take x equals 2 and you plug it in to either the top or the bottom equation. So if I do that, I get 3 times 2 plus 6y, which I'm trying to find, equals 48. And that gives me 6 plus 6y equals 48. And then I subtract 6 from both sides. Subtract 6 from both sides, and I get 6y equals 42. So, and I divide by 6, and I get y equals 42 divided by 6, so 7. Okay? So now I know x is 2, y is 7, and then what you want to do is write that as an ordered pair, 2, 7. And the last thing you should really do is check. Good. And I've already found y by plugging into this equation, so I probably want to plug both x and y into my other equation to see if they make this relationship true. So I'm going to take 2 and plug it in for x, and 7 and plug it in for y up here, and see if it makes negative 32. So 5 times 2 minus 6 times 7, and you want to know, does that equal to negative 32? And so 5 times 2 is 10, minus 6 times 7 is 42. Does that equal negative 32? Yes. Okay, so negative 32 equals negative 32. So the numbers that I came up with for x and then y must be the correct solution. Okay? Pretty straightforward. Do you want to try one? Why don't you guys try one? You try. No? Yeah, I have a U. Where's my U try? Oh, I don't have a U try yet. What?
Well, we could do steps and then do a U try.
No, I have a U try. Okay. So here's a U try. U try. So here it is. And I could go back to that if you weren't done copying that. So I have 6x minus 3y equals 3. And then I have minus 6x plus 5y is also equal to 3. and I say solve the system. See if you guys can come up with what you guys come up. If I did do it, I would get x equals 2 and y equals 3. And those cancel out. You get 2y equals 6. So y equals 3. And then you plug in to either one, and you would come up with x equals 2. But when you write that answer, you write it as an ordered pair x first, then y. Okay? So those are relatively simple solving by elimination problems. But unfortunately, it gets more complicated than that. Don't you hate when that happens? Okay? So to solve a more complicated one, sometimes you get something like this. 2x plus 5y equals negative 22. And 2x plus 5y equals negative 22. And 10x plus 3y equals positive 22. And you say, well, that doesn't look like anything I've seen, because if I add this, I get 7. If I add this, I get 8. Nothing's going to disappear. So what you have to do is you have to modify the equation such that when I do add them, something will disappear. What can I multiply 2 by to make it into 10? 5, right? So what I'm going to do is I take this whole entire top equation, which I'm allowed to do, and multiply it not by 5, but by negative 5. Because I want things to disappear when I add them. Good? So I'm going to multiply this entire equation by negative 5. And that turns this one into minus 10x. I have to multiply everything by negative 5. So what's negative 5 times positive 5? Negative 25y. And then this number is going to be a little bit messy. But a negative 5 times negative 22, anyone know what that is? 100. Positive 110. Positive, right? Because you're multiplying a negative times a negative. And then you rewrite this equation straight below it. 10x plus 3y equals 22. And then you add those two equations. So now I have a negative 10 and a positive 10. And those ones I can cancel out. And those add up to 0. So then I have negative 25 plus 3, which is negative, what's that, 22? Negative 22y equals, and this works out to, is it 88? 98? 88. 88. 88. And so then I divide by negative 22, and I get that y equals negative 4. See what I did? Yes, ma'am.
Wouldn't you add 110 and 22?
You would. Sorry, I'm dumb. Thank you, Britt. You should have another point.
If you did subtracted, it would
Yeah, you're right. I'm looking at it wrong. So that should be 132. Okay? Thank you. I was sleeping. Okay? So I think that comes out to be 6, right? 6? Yeah. Y equals 6 when I divide 132 by 22. Thank you. Negative 6. Negative 6, you're right. Negative 6. So then I have to take my negative 6 and plug it into one of my original equations. I don't like negative numbers, so I'm going to plug it into this one. Doesn't matter which one you're really plugging in to, but I have 10x plus 3 times negative 6 equals 22, which gives me 10x minus 18 equals 22. I add 18 to both sides, plus 18, and I get 10x equals 30. Whoops, I forgot my x. Right? So x equals 3 by 10, 3 on both sides. So my ordered pair is 3, comma, negative 6. And I'm not going to do it, but I bet if I plug those numbers into this equation, it would show that those are both true. Yes?
So 22 plus 18 is not
40. You know what? I didn't have enough coffee today. Sorry, Justin. But I think my wife is slipping me decaf. She makes a coffee in the morning, and I'm used to having like really strong coffee, and I think she thinks it's good for me. So she's watering down the coffee with decaf, and I have this horrible headache. And if you're a coffee addict, then you don't drink your caffeine. And I still should have sleep. That's why I made mistakes.
You're recording.
Those are the first two mistakes. It's okay if I'm recording. All right.
It's Landon's birthday.
What?
It's Landon's birthday.
This one is even more complicated than the last one, because there's nothing really I could multiply this by to change this into 3. No integer number, right? And there's no integer number that I could multiply this by to change it into -2. So in this case, yes, ma'am.
Would you just multiply by the common denominator?
Very good. That's what you're trying to find in this one. Yeah. What's the common denominator? Yeah, you could multiply by the common denominator, but yeah, that doesn't really work either. Okay. What you want to do, you kind of are on the right track. What you really want to do is get either the x's to be the same or the y's to be the same. So what could I multiply? I think what you're thinking of, what number do they both go into? Right? 6. Okay? So how can I change 2x into 6? What do I need to multiply 2 by to make it into 6? 3. Okay? And I want to change this into 6 as well. So what do I want to multiply that by? 2. Okay? Except instead of just multiplying by +2, I'm going to multiply by -2 because I want one to be positive and one to be negative, so that when I add them, they will disappear. So I'm going to multiply this whole top equation by 3 and this whole bottom equation by 2. And when I do that, this equation becomes 6x plus 9y equals 21. And this bottom equation becomes minus 6x minus times minus makes plus 4y equals minus 2 times 4 makes minus 8. And now I can add them together, and this goes away, and I get 13y equals, oh look at that, 13. So then I divide by 13, by 13, and I get y is 1. And then I take that and plug it into either one of my two equations. So let's plug it into the top one. 2x plus 3 times 1 equals 7. And so 2x plus 3 equals 7. So 2x, subtract 3, right? Subtract 3. 2x equals 4. So divide by 2. X equals 2. So now I know x is 2 and y is 1, and that's my order pair. Okay? So that's a case in which I have to multiply both equations. So either you can add them together and something will disappear, or you have to multiply one equation, or you have to multiply both equations. Now, just so you know, sometimes when you add equations, you'll get something like 5 equals 5. You know what that means? Do you remember what that means? If you get something like 5 equals 5, that means infinite solutions, okay? Meaning it's really the same line in disguise, okay? And if you get something that doesn't make sense, like 3 equals 0, that means that they're parallel lines, and that means no solution, okay? Just so you know, if you end up with something like 5 equals 5, where you don't have an x equals, everything just disappears, that means it's the same line. But if you end up with something like 3 equals 0, that means that those lines are parallel. Parallel lines This means same line, so they lie on top of each other like that. Okay, one word problem, and then
We'll
we're
write out
done.
our steps and then we'll be time.
Oh, and then we'll write down our steps.
Yep.
Okay. So, and then it will be done. So, where's my word problem? First I have the recording again. Special day tickets for minor league baseball teams came for $5 for adults and $1 for students. The attendance that day was 1139 and $3,067 was collected. Write and solve the system of equations to find the number of adults and the number of students. Okay? So let's let x be something and let's let y be something else. What should I let x be? Come on. What are you looking for?
Number of adults.
So I'm going to let x be the adults, okay? And or tickets, adult tickets. And y be what?
Students.
Students, okay? Students. And so what do I know about the total number of tickets? How many tickets did I have? How many tickets altogether? It says in the problem.
1,000.
1,139. 1,139. And then each adult ticket costs $5, and each student ticket costs $1. So what I do is I go 5x plus 1y equals how much?
3,000.
$3,067. Now, there you go. So now probably what I want to do before I add them is change something into a negative. Which do you think would be easier to change into a negative? Top or bottom?
Top.
Let's change the top into negative, and all I really have to do here is multiply this whole equation by -1. And if I multiply that whole equation by -1, it becomes minus x minus y equals minus 1139. And this equation on the bottom stays as 5x plus y equals 3067. Okay? And then I add. What's minus x plus 5x? 4x. What's minus y plus y? No y. Okay? And then you add these, which you're really subtracting, right? Adding a negative and positive. Oh, I can't do that in my head. I need a calculator. Can I do that in my head? Can you guys do that in your head? Justin, what's that? Get that calculator out. Let's just get my calculator. There we go. See, even teachers have to use calculators. I could probably do it in my head. I just don't want to make it. Okay, so I'm going to go 3067 minus 1139, and I get 1928. 1928. And then I divide both sides by 4. Divide both sides by 4. And I get x is 1928 divided by 4. That's 482. Right? So that's the number of adult tickets sold. And since I have 1,139 tickets altogether, I know that 482 plus y equals 1139, 1139. So if I subtract 482 from both sides, y is 1139 minus 482, which is 657?
Yeah.
Sure, if you say so. So y is 657. And that's the way you do it. That's the way.